Hello, NVIDIA creators. My name is James Tralie, and I'm a producer and animator at NASA Goddard Space Flight Center. I render visualizations that communicate complex scientific discoveries to you, the public, in fun and engaging ways. I work on all the planetary science missions and have created anything from a VR experience from the surface of an asteroid we recently sampled to a cartoon animation about charged particles in the upper atmosphere of Mars. Through my work, I often use the wonderful software Blender. It's free, it's fantastic, and there's an awesome community of users really helping develop the software and make it what it is today. There's always new versions of Blender coming out with fantastic new features, and Blender integrates super well with a lot of the new NVIDIA hardware that's come out. I personally use the NVIDIA Quadro RTX 5000 for a lot of my renders now, and I've noticed that with cycles and optics enabled, it is lightning fast for me. So today, NVIDIA has actually asked me to walk you through some of my tips for large-scale environment creation with Blender. I'll show you some of the optimization tricks I use to speed up my own workflow while still maintaining excellent final quality of your renders. I'll talk about scene organization, landscape geometry, and also some extra additions like particles and volumetrics and how to keep them manageable when really scaling up your scenes. Before I even begin designing a landscape in Blender, I found it immensely useful to collect source material and inspiration. I often like to grab a camera and snap some pictures of my surrounding area to get an idea for how light and shadow interact with natural landscapes. When working in 3D, it is extremely easy to lose sight of imperfections that make nature wild and beautiful. Keeping in mind things like bumps, cracks, ridges, discontinuity, and discoloration when building out your scenes will give you such a creative edge when working towards photorealism. If you can't actually visit a place you're trying to recreate in 3D, it's helpful to do an image search online or scroll through location tags on social media, screenshotting or saving the files you find along the way, and then assembling them together into a mood board. Once you have a mood board together, you can move on over into Blender. So for today's tutorial, I'm not going to walk you through step-by-step of actually building these scenes out, but I want to give you some tips on how to make scenes like these on your own and the ways in which I'm always thinking when I'm actually trying to build out these scenes. So the first one I'm starting with here is a recent animation I created. I made both a day and a night version of this, and very, very quickly the scene grew into a very large scale piece with a lot of moving elements for both the animation and also a lot of particles like grass and rocks and leaves that were scattered all across my scene. I was going for kind of a Japanese inspired design for this and really had a lot of fun building out the architecture and natural scene. As you can see here, what I like to do when I'm opening up my interface in Blender is have this small little image preview here where you're almost seeing like a render or another image as a reference. You can even bring in a mood board here. And if you don't have a second monitor, this is, very helpful. You can kind of scroll around in here and look at the details of your scene, the rocks, the grass, the foliage, and the sky, and how the lighting interacts with the surface. Can't stress this enough. It is extremely important to have these natural references because it really does help you as you're working through your render. What you'll also notice about my interface here is this interesting menu down at the bottom where you see a lot of information coming up here. And if you don't see this by default in Blender, I encourage you to go to Edit, Preferences, and then Interface. And then within the interface, you can go down to Status Bar, and then check on Show Scene Statistics, System Memory, and Video Memory. And you can check on the Blender version if you forgot which one you're working with as well. But those three at the top are very important, and they give you an idea of the memory that you're using in your scene. And if you were to click on an object, so say for example, I click on this rock back here, it will tell me exactly how many faces, vertices, and tries that object actually has in my scene. So when you're scaling your scenes up and making them very large, it's really important to keep those numbers as low as possible and optimize your scene as much as possible. So if an object that you're bringing into your scene is going to be far away from the camera, it doesn't need to be very high poly. You can kind of cheat a little bit and get away with lower poly objects. Or if you're going to be reusing the same object. So for example, this rock that you see here is actually the same exact rock that you see here and also here. A lot of these are the same. I've just sculpted them slightly differently and then rotated them so that your eye is actually seeing it as a different object, even though it is in fact the same exact object. Doing this can save you a lot of memory when you're building things out. And a really quick way to actually scale these up and change them around, let me just turn on my screencast keys here for you so you see what I'm doing and clicking on here, is to just actually select the object that you're trying to build out. So I've got this massive Nordic rock here. And instead of hitting Control-C, Control-V, or Shift-D to duplicate this, you can actually just select your object and then press Alt and then D. And this will create a linked duplicate of your object, which actually is not using a lot of memory. And you can quickly move this around and rotate this, scale it up, and move it around in your scene so that it looks like an entirely different rock, but it's actually the same object. I use this technique all the time when building out scenes very quickly, and it's a really fun way to just add some variety to your scene while maintaining a very low poly count as you're working with a large-scale scene. Another super key tip for all of my renders is scene organization. It is incredibly useful to obviously name your files, but more than that, to actually group them into collections. Blender has a pretty decent collection system, and what I like a lot about it is that you can actually, once you're grouping elements into a collection, you can actually hide them from view in the viewport. And what you can do is actually say, for example, I don't want the building to be in my render here. Let me go back to the first frame of this animation. So you see we're looking through and we've got this archway here. We've got this curtain that's set up here. I've put these both in my building object here. So we've got the main room and the curtains here. And if I just hit exclude from view layer, you can now see that's hidden. And this can actually optimize your scene. So if you're doing a very large scale animation like this one here, and I was actually animating the water, it was helpful for me to actually turn off a lot of these elements that I didn't necessarily need to see all at once, and then just look at the objects themselves. So I can actually look at this water animation at a bit higher playback frame rate when I'm playing here. So you can see when I hit play, you can see it's going at a whopping 4 frames per second because this is a pretty dense scene. But this is at least better and kind of gives me a cleaner idea of the animation of that water and also of the grass kind of blowing in the wind a little bit there too. And then once you want to bring them back, you can just toggle it right back on again. Keep in mind too, if you actually put an object in here that you don't necessarily like, so say I have this building in here, but I don't want this to be in my render, actually excluding it from the view layer will also exclude it from your render too. So when you're rendering this out, you can just hide this out there. And this is really helpful when actually compositing elements into your scene. It's a really fast and really quick way to just hide something and then render just that one object. So say I just want to render this building. I could hide everything else and then just render that archway. Really optimizing your scene very well. Thinking with those optimizations in mind really helps you as an artist and as a creative moving quickly through these renders and creating stuff that's fantastic. One comment I wanted to make too about actually organizing your objects. To create a new collection with objects, so say, let me just add a couple new meshes here. I'll add in like a little cube here. Let's add in a UV sphere. We've got these 2 objects and we want to group them in a collection and then be able to move them around. You can actually just select both of them like this, or if you have them in your menu here, you can just click on the sphere and then shift select and click on the cube and then just press the letter M on your keyboard. And then you can add them to a new collection, name it whatever you want. I'm just going to call these objects and then hit OK. And you can see now that it's grouped these into new collections. I find it sometimes helpful to color code these as well. So for objects that are kind of more in my natural landscape or grass, I'll put like a green or a brownish label. And then for other things like lighting, I like to put like a nice bright yellow just so that it sticks out to my eye. This is just personal preference, but it helps me kind of organize things really well. You can do that by right clicking and then going down here and you've got a couple different collection colors to choose from to actually group your objects together. One other thing that's useful too is to say you've got these objects grouped in a scene here together, and instead of doing that Alt-D strategy for each one individually like I was talking about before, what you can actually do is just instance this entire collection, which saves a lot of memory for you as well. And the way to do that is to hit Shift-A and then go all the way down here to Collection Instance, and it'll open up a little search bar where you can type in what your collection is called. Mine was called Objects. So I can just hit duplicate this, and now I've got an instance of that collection. And keep in mind, if you actually change objects in that original collection, so say I move this sphere around, it will actually change the position, rotation, scaling of that object in your linked collection. So just keep that in mind. So if you were trying to modify something in a collection that you've linked or instanced, it's going to have to be sourced from that original object. Otherwise, you're going to have to duplicate it and make something new. But we're all thinking about optimizations here. This is just one way to do that and really speed up your workflow a lot. I get asked quite a bit how I do the volumetrics for my scene, how to optimize them, and how to make them look pretty and work well in animations so that you're rendering things in a quicker time than it would actually take usually. As any artist knows, once you start adding in volumetrics, it tends to really slow down your renders just because there's so many more bounces that the lighting is going to have to go off of before it gets to the camera to render out your scene. When just adding in volumetrics traditionally, what I'll still do often is just add in a massive cube that encompasses most of my scenes. So you can see here, if I just toggle this on in my viewport, I've got this massive cube here that you can see it kind of takes up most of my scene. And this is what has been rendering the volumetrics for my scene. What this actually does a lot is it slows down the render quite a bit, and sometimes the results get a little bit noisy. You really have to crank up your samples to kill fireflies, and even still you're getting a lot of noise. One way to deal with this noise is to enable the new optics denoising, or open image as well. I prefer optics though, I use this quite a bit. In the denoising tab in the latest version of Blender with cycles. It's fantastic and really yields some great results once you're actually rendering these out. So for this animation, I actually had optics enabled. And so whenever it rendered out of frame, it did some really nice cleaning up of the noise. But if you can't do that, if your computer is a bit older and your renders are taking quite a long time and you don't want to go this traditional route with volumetrics, there's a couple different techniques I use to optimize my scenes and still get some really great looking results. The first technique is one that I've talked a bit about before in previous tutorials, but I want to go a bit more in depth here with you as well. And that is actually compositing in a mist pass. And what a mist pass is, if I was to click up here in the shading drop-down menu, you see here, you can see right now I'm using the render pass combined. So this is all of the compositing combined on itself. What you can actually click on instead of doing that combined is to just go over to data and mist. And if you click that, now you're seeing something interesting, a grayscale image. And you can enable the mist pass here in the data passes. So that's an important one to enable there when you're actually rendering this out. So what you're seeing here is an information about the distance of objects from your camera here. And you can actually manually define this distance. The darker the image that you see here, the closer it is to the camera. And the whiter, closer to pure white, the further away the object is. And you're getting an interesting result already here. You can kind of see some interesting outlines of the lanterns, of the trees, of the rocks, and the mountains in the distance. And it already gives a really interesting effect here. So now this just at face value is going to look kind of weird if you're just, rendering out an image in black and white like this. But we can actually composite this into our final render and actually control the parameters that are defining this mist pass here without actually having to add in any volumetrics in our render. It's just going to save out an additional pass that we can then composite in. To start, you're actually going to want to click on your camera tab here. If you go down to your camera and then scroll all the way down, you go to viewport display and you want to click on show mist. And so what this is now going to do, if I toggle this on and off and show you my camera, is you see this interesting line here. So if I click this on and off, that's now hidden in the viewport. I can bring this mist layer back. And so it adds this line. And what you're seeing on this line are 2 points connected here. You've got this one point right here. And all the way back in the distance here by these mountains is this second point right here. And the distance between these two things is what's actually influencing the grayscale image that you see on the right of the viewport. The way to actually control that fall off there is by going to your World Properties tab here, and then going over to Mist Pass, this drop-down window that you see right here. And now you have this distance in meters here for me. The start distance of the mist measured from the camera, and is currently by default set to 5 meters away. So you can see this point here is a 5 meter distance from our camera. And then that endpoint all the way down there is at 25 meters away. You can also influence the fall off as well. I find that quadratic works the best for me to get a really nice smooth kind of fall off into the distance. But what you're going to want to do potentially, depending on your scene, is actually change the distance of these mist passes. So if I were to set this all the way back to 0, you can see it seems a lot more washed out because that fall off is immediately starting from 0 meters from where the camera is. If I crank this way up, so let's put this at 22 meters, the scene is going to be a lot darker, and you're just going to see that fall off really far in the distance. So by controlling that influence and that difference between these two can yield some really interesting results. And once you're actually to render this out, the way to composite this in is to go to your compositing tab, hit on use nodes, and you actually will see an additional option here. In addition to just image, alpha depth, and noisy image, you'll get this little thing here for mist. And you will actually be able to save this out if you add in a viewer node here. I'm going to add in a viewer node, and I'm going to click that into image. I usually like to just export these separately. You can render these out at the same time, and composite them in. I usually find it easier, for me at least, to composite in a program like After Effects after the fact. But if you want to composite this in Blender, that is possible too. But that's a really quick way for you to save some time and energy and get back to making some really awesome renders without having super crazy volumetrics. So if I switch back onto combined mode here, I'm going to talk about my second technique for volumetrics, which is a little bit of a cheat hack here, but you still get some pretty great results. And the way to do this is by using image planes as emission textures. So if, for example, I wanted to add in a bit of billowing fog here, I can go actually to Edit Preferences, and then Add-ons, and make sure you've enabled the add-on Images as Planes, Import Export Images as Planes. Click on that, and then what you'll now have is an option when you hit Shift-A to, in addition to just importing meshes, you can go all the way down to Image, and now you can import images as planes. And what you'll notice is that once this is imported, let me add this to my lanterns and lighting, or my lighting tab here, camera and lighting, slow diagonal drift steam. If I scale this up a lot and pull this up a little bit more into the foreground, you're going to notice something immediately here that is kind of off. And that is that we're actually seeing the background still here. So sometimes this glitch happens here when you import things into Blender, where it's plugging it into a mix shader here. And what I actually find to be a bit better technique is to import it into an add shader. So keep all these same nodes, but we're just going to plug this into an add shader instead and pump that into our surface output instead. And then there we have it. We've got rid of our background by using a transparent BSDF, and we can control the brightness of that steam by this emission here. So if I crank this up a bit more, we're going to have some nice bright steam here. So one issue, however, is this plane actually is acting like an object in our scene and is blocking the transmission of light through it. So if I was to shine a really bright sun lamp or something through this, it would actually cast a massive shadow of this plane, which we do not want to have that harsh a plane shadow in our scene. So to get rid of that, I'm going to go to the Object Data Properties and then scroll all the way down to Visibility. And in the Visibility, we're going to go down to the Array Visibility tab and just uncheck Shadow. So this just gets rid of the shadow of this. And just like that, there you have it. The one thing that's important to keep in mind, though, is you want to make sure this is oriented with your camera, with the plane of your camera. So right now my camera is at perfectly 90 degrees with this. So it's perfectly lined up, perfectly parallel, and it's going to work well. So if my camera, for example, in the scene is moving forward, that steam is actually going to look like it's 3D, even though it's a flat 2D plane. However, if we were to kind of turn this camera around or kind of move it slightly, it would look a little bit strange and a little bit off center. So one thing to keep in mind is if you're moving your camera around, what you might want to do is actually link these objects together so that it's following this as its parent. So if I click on the slow diagonal drift stream and then control click on the camera, and I'm going to hit Control P, and what I can do is set the parent to the object. So now what you've noticed is it's actually underneath our cameras added in this slow diagonal drift stream, so that when we're actually moving our camera around, the stream is staying in the same position, or the steam is staying in the same position relative to our camera. So this works really well if you're moving through a scene. You can also still keyframe this so that it's moving forward a bit or rotating, but this is helpful to make sure that it's staying with the same plane of the camera of your scene. All right, and I'm back here for part 2 of this case study here. I wanted to walk you through how to add some particles and make sure you're optimizing your scene with some of these particle additions. All right, and for the second scene, you can see it right here. This is a really fun piece that I put together using a lot of really fun nature assets that I sourced from some add-ons that I'll be talking about in a lot more detail in the next tutorial for NVIDIA, where I talk a lot more about the best add-ons for environment creation. Anything from ones that help you scatter particles easier to ones that help you actually light your scene a bit better. But for this one, I just wanted to give a little shout out to one add-on in particular and talk about ways to optimize particle emission on your scenes and how to actually keep moving quicker and make sure that you're not bogging down your viewport while you're working, and also optimize your renders ultimately too. So if you're looking at the scene here in Blender, it looks a little bit funky, and that's because you see all these little cones here, which are actually taking the place of the particles that are being scattered here in the first place. So I used an add-on called Grasval for this one, a really fun one here. It's got a free version as well available, but I used the paid one for this. And what's nice about it is when you actually scatter an add-on, so in this one I scattered some grass particles on the scene, you can have the option to use proxy particles in your viewport. So you're not actually seeing the very, very high poly grass particles, but you're actually just seeing these kind of cone-shaped things instead, which are incredibly low poly and allow you to have much faster playback in your viewport. You can see I'm pretty close to my target frame rate at 24 frames per second here when I'm actually playing back in the viewport, which just wouldn't be possible if you're using a lot of these high poly grass particles. And what's nice about it is if I scroll down here, you can see I can actually change the optimization in this optimization tab in the LODs, which is level of detail is what that stands for. And you can see in the final render, I'm obviously going to use the high poly render that I want. But in my viewport, I can actually have it as low or even proxy. Scattering particles is also extremely easy too. And what I recommend is when you already kind of know how certain particles will look in your scene, you can actually just turn it off in your viewport. And so that it's not actually even there. So you're just seeing one, you can just work on one system at a time and kind of just go at things piecewise. I think it's the most useful approach when working at these things is to just take it piecewise, work at one particle system at a time, and make sure that it's looking proper, how you want it to, and that it's filling up your scene really, really well. For the next tutorial, I'm going to go into a lot more detail on this, so stay tuned for that. But I hope you learned something from this, and I hope that for your next environment creation, you are going to be not only moving much quicker through it and actually creating something exciting in the viewport with not as much lag, but you're also going to be making something extraordinary too. I can't wait to see what you come up with. Be sure to share it with me and be sure to follow along in the next tutorial. Thank you so much, NVIDIA creators.